So, hello everyone again. This is lecture number 7 part 1 of current electricity. This may be the last lecture for your current electricity portion. So, in the previous lecture we ended with the meter bridge discussion. I will revise a part of meter bridge and then we can move on with the potentiometer. After potentiometer it is just the summary of the current electricity and the chapter will be completed. So, I am Sameer Lavankar. Let us begin our discussion. So, the course outline for you first of all. So, first of all we started with the first part, that is introduction, in which we understood that how the electricity is generated. So, basically when the electric charge is at rest, then the electric charges are not generated, the current electricity is not generated. When these electric charges go in movement or when they move in motion, then that constitutes something which is called as or which is defined as electric current. Then the second part of in concept of electric current, we understood the basic mathematical formulation of electric current, that is, let us suppose there is a area A through which the amount of charges pass from left side to right side or from this portion to this portion, and let us suppose that in time t the portion of or the charges q goes from left side to right side is, let us say, q in some time t, then the electric current is defined as small q by t. In infinitesimal method, this is nothing but limit delta t tending to 0 del q upon del t, which is defined as nothing but electric current. In electric current in conductors, we understood one of the concept that what is the difference in the material of conductors, semiconductors and insulators, in which also understood that the basic confinement or basic fixity of a charge is if the electric charges are very free to move, then it is called as conductors, and as the rate of or the portion or the capacity of these electric charges to move freely reduces, the material gets changed to semiconductors and finally to insulators. So, these all things are understood in the third point. Then in the Ohm's law we understood the very beautiful concept of V directly proportional to I by Ohm's. So, by removing the proportionality sign we knew that V is equal to nothing but I into R, where R is defined as resistance or R is called as resistance in ohms. Moreover, we also understood that R is directly proportional to L upon A, and when we removed this proportionality constant we got R is equal to rho L upon A, where rho is nothing but resistivity. So, these all things I am just telling the brief parts. For the detailed discussion you can go to the subsequent lectures. So, we understood the concept of resistivity. Then the fifth point of drift of electrons and the origin of resistivity, we understood a concept called as small vd, that is why the basic importance of this drift of electrons has to be understood, as in to understand why at the moment we start the electric current or we click on the switch, the light is erupted at that instant only. There is not much time lag even if the size of the conductor is very large. So, we understood even if the value of Vd is small, why is there a electric bulb glowing, or why is there a electric current passing through, let us say, any conductor or resistor or any material very instantly. So, that complete concept was being understood in this concept. Also origin resistivity. So, basically the conductivity concept, that is nothing but 1 upon rho concept, was being understood in this chapter at the last of this fifth point only. Then the sixth point we understood three limitations of Ohm's law, in which two devices were being understood. One was a diode, in which when you try to remove or when we try to inverse the potential difference, then the graph is not the same in the third quadrant. Also we understood a concept of a device called or a material called as gallium arsenide, called as GAAS, which does not follow the Ohm's law, that is V is not always proportional to I, it shows a deviation. Okay. Then after that, in the seventh concept we understood that there are two types of resistors. We also understood the concept of color coding of the resistors. Basically there are four types of color codes. Last one tells you about the tolerance, the second tells you about the multiplier, that is 10 to the power how much, and the first two are the significant digits. Then the temperature dependent resistivity, we understood that the conductors and the insulators has an effect which is inverse towards the temperature. So, this thing has been understood in this temperature dependent resistivity. So, we basically understood why the temperature coefficient was being understood there. So, alpha concept came into picture, that is, if we understood the concept of linear dependence of temperature, then temperature at some time t or the resistivity at some time t, rho t is equal to rho naught into 1 plus alpha delta t. So, that all concept were being understood in this 8th point. Then the 9th point of electrical energy and power, we understood that how the energy is being generated using electric current. What is power? So power is nothing but the product of V into I, also called as I square R or V square by R. And why a transformer is needed, how we try to reduce the dissipation or leakage of energy from the electrical factory to our homes. Of transformers required there, why is there a transformer required, what is the use of transformer, what is the thing required before a transformer, why is there a voltage increase before transformer, and so on were being used, were being explained in this 9th point. Then the next point of 10th, combination resistor series and parallel, we understood two different points. So basically resistors can be either in series, or they can be in parallel. So basically when they are in series, we understood the concept of R equivalent is equal to R1 plus R2 plus dot 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 till Rn. Similarly in R parallel, we understood 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus dot 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 till 1 by Rn. So these things are being understood in combination of resistors. Then cells, EMF and internal resistance. So basically a new concept called as EMF, that is electromotive force, was being introduced, and also we understood a simple concept that even a power battery or anything which supplies voltage also has an internal resistance to it. So the complete resistance is not only due to external resistors, it is also due to resistors which is internal resistance. So basically R equivalent is equal to capital R, that is the R equivalent that due to external resistors, plus small r. What is small r here? Small r is internal resistance. Okay. Next was about cells in series and parallel. So basic formulations for cells in series and parallel were being also formulated in this 12th point. After these all things were the applications of current electricity. So first was Kirchhoff's rules. So why was there a need to explain, or why was there a need for Kirchhoff's rules? So every concept or every complete sequence or series of resistors and parallel combination of resistors can't be explained or can't be utilized to understand how much amount of current is passing through each of them, because for complex resistors it is very tedious to use only combination of resistor series and parallel concept. Therefore two different rules called as loop rule and junction rule were being utilized, were being explained in Kirchhoff's rules, and then the applications of theirs that was being utilized in the further sequences of current electricity. So Kirchhoff's rules in 13th point we understood these two rules, known as loop rule and junction rule. Then the 4th point, Wheatstone bridge, we understood the concept of what is a Wheatstone bridge, how can we find out the value of the unknown resistor R4, knowing that we know the resistor's value of R1 by R2, R1 and R2 by changing the value of R3, or let us say if the unknown is R4, by changing the value of R3 we can get the value of R4 only and only when the balance condition is obtained. What is a balance condition? Balance condition is a condition such that the ratio of R1 by R1 and R2 is equal to the ratio of R3 by R3 and R4. Only and only when the value of current passing through the galvanometer is 0. What is the galvanometer? Which is that balance circuit here. So these are the balance arm and these are the cell arm or the battery arm. Okay. Then right now we are on the meter bridge. I guess meter bridge is also completed in the last section only, but I will revise this again and then we will move on with the potentiometer concept. Okay, so let us start our discussion now. So first is meter bridge. So in the last lecture I explained you what is happening here. So basically this is the wire which is of meters, basically this is 100 centimeter scale. So if when you are using this jockey to put a sign here, so basically we are making nothing but a Wheatstone bridge of this portion and this portion here. So this divided by this ratio is equal to this divided by this ratio here. Therefore what we got finally was that if we need to find out the value of resistance capital R such that this S is known to us, then what we will do? We will do nothing, we will just find out a value of portion of this with the jockey such that the current passing through this galvanometer is 0 or the deflection is 0. So how do we do this? We just find out by using mathematical formulation. I guess these all things are being explained. Finally what we got is capital R, that is unknown resistance, is nothing but S into L1 upon 100 minus L1. So basically R, which is unknown parameter, let me write just again, is equal to S, which is known parameter, multiplied by L1 upon 100 minus L1. What is L1 minus 100 minus L1 here? So basically when we are trying to put the jockey, let us say at this portion, we know that the complete length of this wire is 100 centimeter. Therefore, if the length towards the left hand portion is L1, then the length towards the right hand portion will be nothing but 100 minus L1. Therefore, what we got is for the meter bridge, if we need to find out the value of unknown resistance and such that given that we know the value of known resistance S, then R unknown is nothing but equal to S known into L1 upon 100 minus L1. So, this thing was been explained. So, let me just read this last 3 lines and then we will move on to the potentiometer. So, by choosing various values of S, we would get various values of L1 and calculate R each time. So, an error in measurement of L1 would naturally result in error of R, quite evident. Let us say suppose we take this value here, then the value of L1 will also change. Similarly, 100 minus L1 will also change, therefore, the ratio, complete ratio will change. If the complete ratio is changed, then the value of S known multiplied by this ratio will change, and hence the obtained value of R is also changed. So, therefore, an error in L1 can also result in error in R. So, this thing has been explained. Next point is, it can be shown that the percentage error in R can be minimized by adjusting the balance point near the middle of the bridge, that is when L1 is close to 50 centimeters. This requires suitable choice of S. So, this thing was also explained in the last lecture only. So, basically what does it say is, let us suppose that first of all, the criteria to use meter bridge to find the unknown resistance R should be, the first criteria should be, you should know the range of capital R. What does it mean by range of capital R? Range of capital R means at least you should know that either it is in, let us say 10 to 50 ohms, or let us say it is in, or let us say it is of 10 to the power 3 to 10 to the or 10 to the power, what we can say, 10 to the power 3 to let us say 2 into 10 to the power 3 ohms, or let us say it is of 10 to the power 6 to 2 into 10 to the power 6 ohms. At least you should know the range of capital R. Why it is necessary? So that you can use the value of known resistance S in that range only. So, let us suppose you are required to find the unknown resistance capital R which is in the range of 10 to 50. So, you must use the value of, so let me write at second point, the S should be used of let us say 25 ohms. So that when we try to vary the portion, the value of L1 should be approximately in the range of let us say 40 to 60 centimeters, very close to 50 centimeters. Let us suppose for an example, we are using 25 ohms in the place of resistor which is of the order of 10 to the power 3 to 10 to the power 3. So, it is 1000 ohm, very large value of resistor is being required here. Therefore, what will happen is this value L1 and 100 minus L1 has to be such that this ratio is very high. For that to occur, this value of L1 has to be either very small, or this 100 minus L1 has to be very large, or 100 minus L1 has to be very small. So, in either of the portions, the value of this jockey has to be somewhat here, which is not close to 50 centimeters. Hence, it will give much more error result. So, to rectify this so as to improve our accuracy, what we try is we just need to know the range of the unknown resistance R, and due to that we will take a resistor known as such that the range of both of these resistors are in the same range, and hence we can find out more accurate value of the unknown resistance. So, that was the complete concept of the second point, and this is the complete concept of meter bridge. So, finally what you should remember is just this formula, that capital R is equal to S into L1 upon 100 minus L1. How is it obtained? It is obtained using the balance point which we understood in the Wheatstone bridge concept, that is R1 by R2 is equal to R3 by R4. So, that is the end of meter bridge. Let us move on with our discussion of potentiometer now. So, this is the final concept of potentiometer, and then after this the summary will be dealt with, and that will be the end of current electricity. Okay. So, a potentiometer. So, as you can see, this is a typical diagram of how a potentiometer is being utilized. Please do not get scared with the diagram, I will try to explain each and everything here. First of all, let me just iterate what is written here. So, potentiometer, this is a very versatile instrument. It is basically a long piece of uniform wire, sometimes a few meters in length, across which a standard cell is connected. So, basically what is a potentiometer? Again, nothing but it is a wire which is connected with a battery, nothing else. This is nothing but a more complex nature of how a potentiometer must look like. But what is a potentiometer? It is basically a wire which is connected through a cell or a battery. Okay. So, basically a long piece of uniform wire, sometimes a few meters in length, across which a standard cell is connected. Okay. In actual design, the wire is sometimes cut in several pieces, placed side by side and connected at the ends by thin metal strip. So, this is nothing but what is happening here. So, basically what we can do is, if we need to explain to you what is a potentiometer, I can just make a cell and I can connect a wire here, and that is your potentiometer. But just to explain more, just to use a little less size to put the complete setup, what we do is we cut this into several parts like this. So, let us say this is one, let us say these are the different parts. So, L by 4, L by 4, L by 4, L by 4 length is being used, and how are they connected? They are connected by a metal strip. So, they are connected like this by a metal strip. So, this is nothing but what is being done here. So, there is nothing to be let us say hard concept. There is no hard concept here, not tough concept here, very easy concept. Okay, so what is happening here, just we are cutting the wires. So in actual design the wire is sometimes cut in several pieces placed side by side. So it is placed side by side, as you can see, placed side by side here, and connected at the ends by thick metal strips. As you can see, these are the thick metal strips being talked about here. These are the thick metal strips. Okay, let us move on. In the figure the wires run from A to C, quite evident. As you can see, the wire starts from here, goes here, like this, like this, like this, like this, like this, and like this. Basically the wires are in this portion. Let me just make the diagram more clear. So wires are this only, 1, 2, 3, 4, 5, 6. So basically if the length of the wire is capital L, then it is divided into L by 6, L by 6, L by 6, L by 6, and so on. Okay, so this thing has been explained. Let us move on. What is written up after this? So in the figure the wires runs from A to C. Okay. Next is the small vertical portions are the thick metal strips connecting the various sections of the wire. So these are nothing but the thick metal strips connecting the portion, other different portions of the wire. Okay, so this thing also been explained. A current I flows through the wire which can be varied by a variable resistance. A new concept has been evolved here, not a new concept, new word has been evolved, something called a rheostat. So what's a rheostat? Rheostat is nothing but, it's a device which can vary its resistance, which can vary its resistance. So that is called as a rheostat, nothing but. So that is only written here. So basically in place of capital R we can just put R only, but that R is variable. R can be 100, 150, 200, and so on. Okay. So current I flows through the wire. So a current I is flowing. Why it is flowing? Because the circuit is closed and the current can flow like this. Okay. So a current I flows through the wire which can be varied by a variable resistance, which a variable resistance is nothing but a rheostat in the circuit. Okay, so just a current I is flowing, quite evident that if there is a wire, if there is a battery, if the circuit is closed, and the current will flow through the wire, quite evident. Since the wire is uniform, as it is written here, it is a long piece of uniform wire. So since the wire is uniform, the potential difference between A, this is A, and any point at a distance L from A, let us say this is the distance L from A, is nothing but epsilon L is equal to phi into L, where phi is the potential drop per unit length, quite evident. If the potential drop, see, let us move on with the complete concept again. So there is something called as a battery. Battery will have some potential difference phi, means complete potential difference capital V. Now where will that capital V potential difference be applied, or who will absorb that complete potential difference? There is only a wire standing there, so the complete potential difference will be applied, or a complete potential drop will be happening through that wire only. Now what they are doing is they are implying something. They are just saying that the potential drop which is happening towards complete wire is, let us say, capital V. That means what is happening is, let us suppose the potential drop happening per unit length is by L is defined as phi, nothing else. So if we need to find out the value of potential drop happening in per unit length, or let us say till point n1, if you know this length, let us say I sum this, sum this, sum this, and sum this, I get a length smaller, so it is nothing but phi multiplied by L. Hence this thing has also been explained, that is the potential difference between A and any point at a distance L from A is nothing but epsilon L, which is equal to phi into L, where phi is the potential drop per unit length. Quite evident, I explained you this point also. So till now what we understood is there is a potential difference happening till every point. So for potential difference of n1, so for length L1, so let us say the length till n1 is, let us say L1, and let us say the length till n2 is, let us say L2, then the potential drop by AN1 will be nothing but phi L1, and the potential difference of potential drop from the length A to N2 will be phi L2. Okay. So for now let me stop it here only. I will move on with the further discussion in the next lecture. and then we will move on, then I can understand you, then I can make you understand what is actually potentiometer, why we are doing this much thing, why we are cutting, why we are trying to derive something called as rheostat, why we are using various resistors and so on. So let me stop it here only, I will move on with the further discussions from this. So thank you for now.